This is a quick review of 7.3. We're going to be talking about perfect square trinomials. Now, if you recall, we talked about special patterns in Chapter 6 when we were squaring a binomial. For example, here was a binomial, two terms, and we're squaring it. We talked about that pattern. If you remember in Chapter 6, we said, well, this is going to be, if I was to multiply this out, it would be x, this squared. It would be 3 squared, and then it'd be the 3 times the x, all right, doubled. And so you would end up with x squared, this becomes 6x, and then 3 times 3 is 9. So that was that special pattern that we talked about squaring a binomial. So we squared a binomial. So this is squaring a binomial. But the answer we get is what you call a perfect square trinomial. So now what they're going to do is they're going to give you this and ask you, you're going to recognize, is this a special pattern that will turn around and give you this? So we're going to look at it. If I was to give you the x squared plus 6x plus 9, here's how you're going to test to see if it is a perfect square trinomial. The first thing you're going to do is you're going to say, is this a perfect square? In other words, if I take the square root of x squared, I get x, because x times x, so that's a perfect square. I look at the end. If I take the square root of 9, I get 3. In other words, 3 times 3 is 9, so that's a perfect square. So I've checked the first term and the second term. They are both perfect squares. Now I've got to check the middle term. Now if you recall, the middle term here is all about, if you take this times this and you double it. So what you're going to do is you're going to ask yourself, okay, well this is x, and this one was 3. So 3 times x, is this 3 times x doubled? Well, 2 times 3 times x, right, is 6x. So the middle term tests out. Also, this is positive. So you could say this is a perfect trinomial. All right? So if this is a perfect trinomial, if I give you this and I tell you to factor it, you're going to end up writing it like this, as the x plus 3 squared. Let's just look at another one. Let's just consider these three here. All right, so we're going to look at it. Is this a perfect square? Yes, because 3 times 3 gives me 9. Is this a perfect square? Yes, because x times x gives me x squared. And if I take 3 times x, I get 3x. And if I double that, I get 6x. So that works. This is a positive, right? But notice the middle term here is a negative 6x. And the middle term here was a positive 6x. And so since this is positive, we ended up with x plus 3 squared. But since this is a negative, we're going to get x minus 3 squared. So this here is a perfect trinomial, and it factors into be x minus 3 squared. Let's test this one. This one here is a perfect square because 3 times 3 gives me 9. This one is 2x times 2x gives me 4x squared, so that's a perfect square. If I take 3 times the 2x, I get 6x, but if I double that 6x, I get 12, right? So if I double it, if I double this, I get 12x. So the middle term checks out. So you know this then is a perfect square. So you can write this as 2x plus 3 and square it if you were to factor that. Let's test this one. Is this a perfect square? Well, sure, it's a perfect square because 4 times 4 gives me 16. 3x times 3x will give me 9x squared, so that's a perfect square. Now if I take the 3x times the 4, right, the 3x times the 4, and I get 12x, but if I double that, So I got to double it, right? I double that, do I get what they have here? Yes, I got a 24x. So this then is a perfect trinomial, where it is 3x is the first term of the binomial, 4 is the second term, and notice I'm going to use the sign of the middle term, so it's going to be -4. Here again, I use the sign of the middle term. I use the sign of the middle term. So that's how you're going to be checking to see, is it a perfect square trinomial? Why is that important? Here's the general formula of it. It just says that a minus b squared is the same thing as a squared plus b squared. Keeping the same signs, you double this, right? So remember, when we're factoring a polynomial, the first thing you're going to ask yourself is, you're going to say, is there a greatest common factor? That's what you did in the last section. You're going to factor that out if there is one, okay? If there's not, then either way, if you factored it out or if there's not one, the second thing that you're going to ask yourself, or you're going to look for special patterns. You're going to ask yourself, is it a perfect square trinomial that we just talked about? Or is it difference of squares? And we'll talk about difference of squares in the next section. So there's two patterns you're going to check for when factoring a polynomial. So let's look at this one here. Here I have x squared minus 8x plus 16. They're asking you to factor. That's the directions. Factor. Okay. So the first thing you're going to ask yourself, is there a GCF? Okay. Well, this one doesn't have an x. So they don't have an x in common. And the only common factor they have is 1, because this is a 1x. So there isn't a GCF. So next you're going to look for a special pattern. So you're going to ask yourself, okay, let's see, is this a trinomial square? Well, this is x times x. Yeah, that's a perfect square. This one is 4 times 4. That's a perfect square. And if I take x times 4, I get 4x. If I double it, I get 8x. That tests out. So that means that this is a perfect square trinomial. So it's going to factor to be x and the 4, same sign as the middle term, squared. And we've just now factored it. This becomes this factor. And that's it on the factoring. Let's look at another one. Now look, this is x squared minus 8x plus 16. X squared minus 8x minus 16. Notice it's the same thing except for this sign right here. All right, this is not a perfect trinomial, even though this is x times x and this is 4 times 4, but because this is negative, it is not a thing, so it can't be factored. All right, it doesn't apply. All right, and let me just show you that. Well, you must say, because this here is going to give me a -4 times a -4 is going to give me a positive 16. If it was a positive 4 times positive 4, it's going to give me a positive 16. So no matter what I put here, I should end up with a positive third term. And this is not positive. So this does not check out. It does not check as far as being a special pattern. So you can't factor that at this time. Let's look at this last example. Again, is this a perfect square? Yes. 3x times 3x gives me 9x squared. 5y times 5y, that's give me 25y. This is positive, so you got to check that, right? So that works. Now let's check for the middle term. I'm going to take 3x times 5x, 3x times 5x, which gives me 15x. If I double that, I should get 30x. Oh, I'm sorry. 3x times 5y, sorry, because that's a y. 3x times 5y gives me 15xy. Then if I double that, I should get 30xy. I didn't get 30xy. This is 20xy, okay? So because this middle term did not check, right? Doesn't check out, right? then this is not a perfect trinomial. Here's another problem. Now this one looks a little different because it has this binomial squared. But that's okay, because what this means is x minus 2 times x minus 2. So it's still a perfect square. And then we have 4 times 4, so that's a perfect square. This is positive, so we're good there. Now let's check our middle term. If I took 4 times the x minus 2, and then I doubled that, right? I would end up with the 8x minus 2. So the middle term checks out. So that means that my answer is going to be x minus 2, right? Same sign as that, plus 4. This squared. Excuse me. So that would be your answer right there. Is this a perfect trinomial? Well, let's look. X times x, that's perfect square. 3 times 3, right? And this x minus y squared too. So this would be like 3x minus y times 3x minus y. So this is a perfect trinomial. Now let's check, and this is a positive. So let's check the middle term. If I take this here, this 3x minus y times x, okay, and then I double it, would I get the same answer? And I'm going to put this x here because 3x times 3x will give you the same thing. Well, 2 times that gives me the 6x times that. So this is that doubled. So it checks out. So that means that my x, keep the sign of the middle term, right? And then here we had 3x minus y. And since these are already in parentheses, we're going to have to use brackets. That would be that squared. And this checks out. I'd like to do one more for you. I hadn't really picked out another one. Oh, yes, I guess I did. Good. Good. So let's look at this. Here we have, we're going to ask ourselves, is this a perfect square? Well, this is not a perfect square because x times x does not give me x squared. So you see how that's not a perfect square? And this is not a perfect square. But what's the first thing you're always supposed to ask yourself when factoring? When they ask you to factor, the first thing you're going to ask yourself is there a GCF? Is there a common factor? Well, yeah, they each have at least an x. So if I factor out that GCF, which is x, I factor it out, I'm going to get x times what gives me x cubed, x squared. X times what gives me negative 8x. That would be negative 8x, right? And then x times that would give me 16. So what I did first was I factored the GCF out. Then you're going to look at inside, and here you have a trinomial. And so the second thing you're going to ask yourself, is there a special pattern? Right? Is there a special pattern? So is this a trinomial square? Well, I'm going to look at it. This is 4 times 4, so that's a perfect square. This is x times x, so that's a perfect square. If I take 4 times x and I double it, I get 8x, right? So, and this is positive. So this works out on our term. So I'm going to write this x, I'm going to bring it straight down, and then this right here is going to be factored to be x, keep the sign of the middle term, plus 4. Remember the x, sign of this, and plus 4 squared. So this is this factor. x times x minus 4 squared. And we've now factored that trinomial. Here's another one. First thing you're going to ask yourself, is there a greatest common factor? Well, they're all divisible by 4. Right? This is divisible by 4, 32 is divisible by 4, and 64 is divisible by 4. So my GCF is 4. So I'm going to take out a 4, factor that out, and I get x squared. 4 goes into 32, 8. 4 goes into 64, excuse me. 6. Okay, check it. 4 times x squared is 4x squared. 4 times negative 8x is negative 32x. 4 times 16 is 64. So I factored out, did that reverse distributed, right? And then you're going to look again. You're going to ask, okay, is there a special pattern that I can take out? Well, is this a trinomial square? Well, this is a perfect square, right? X times x, 4 times 4, right? So we're going to get 4x when we multiply that individually. If we double that, we get 8x, and this is positive. So this will factor, this trinomial here will factor to be x, keeping the sign of the middle term, squared, bring down your 4. So here is your final answer. We've now factored this trinomial to be 4 times the quantity x minus 4 squared. We'll look at one more. Okay, is there a GCF? Well, the coefficients are all divisible by 2. This has an x cubed, an x squared, and an x to the first, so they all have at least one x. So I'm going to factor that out, a 2x. When I factor that out, 2x times x squared gives me 2x cubed. 2x times 2x gives me 4x squared. But it's a y here, so I have to say it this way. 2x times 2xy gives me 4x squared y. And then I take a 2x over here, I'm left with y squared. 2x times y squared is 2xy squared. So you got to double check to make sure when you're taking that out. So this is our GCF. Then you're going to look at the new trinomial that's inside, and you're going to ask, is it a special pattern? Is it a trinomial square? Perfect trinomial square. Well, x times x gives me x squared. Y times y gives me y squared. And xy, if I take those and multiply them, and then if I double it, did I get the middle term, and is this positive? And so it all checked out. So this is a perfect trinomial square. So that means I can factor this as x, keeping the sign of the middle term, and y, and square it. So this now is your complete answer. You can always do your check step. You can multiply this all back out, and you should end up with what you started if you're doing your check steps. So I've now factored this trinomial.